All right, colored pens. Today's warm-up is a challenging question that involves a number of different ideas that we've studied so far this year. So part A, you were asked to write and simplify an expression. So first I want the expression not simplified, and then I want the simplified form. So part A actually has two different answers. What was the expression before you simplified it? We'll start with Briante, Jedley, and then Caesar.
10 times 4 times x divided 2.
Okay. Okay. What'd you get, Caesar?
4 times x plus 10 times x.
Okay. So they were all similar, but this is really what I was looking for. It's added together. So you can't have it all multiplied, and I'll explain why in a moment. 4x is actually the rectangle, and then 1/2 times 10 times x. So you could actually put the 1/2 and the 10 and the x in any order that you would like. So if you put the 1/2 over here, or the 10 over here, and the 1/2 here, it doesn't really matter.
What if we put the half 10x before the thing?
That's fine as well. This whole expression could be over here, and the 4x could be over there. Very good point. Thank you. When you simplify it, what do you get? Gary?
9x.
9x. Now, I went further and I said, well, the area of the whole thing is 108 square inches. What's the value of the missing side? So what do you get? We'll start with Kevon, Sebastian, and then Valerie.
12 inches.
I'm sorry?
12 inches.
12.
12.
You two agree. Okay. That's good. Comes out to 12. 12 inches to be exact. So this was not easy in any way. But you were supposed to have been introduced to the concept of a complex figure. And what you're looking at here is a complex figure. This right here is a complex figure. A complex figure is a shape made up of more than one regular figures. So, how do you work with it? One way to work with it is to separate it into its recognizable shapes. So watch what happens when I white out part of the figure. Watch what happens when I take this and now let's look at that. What shape do we have now? So let's pretend that the other part didn't exist. What shape do we have? It's a simple question. I should see every single hand. What shape do we have? Mia? A triangle. Good. Now we're talking about area. It says for the area of the figure. So let's forget about the other part of the figure. Let's just concentrate on this part. How do I write the area of a triangle? See, it's unfortunate that you missed one little hint that the teacher actually put right up there for you. Valerie? Yeah, I wrote it right here for you. Area equals half base times height. So we need to write an expression to represent this. So we need half the base times the height. Now, because it's all multiplication, we can actually do it in any order that we would like. So if we would like the h to be over here and the half to be over here, or the b to be over here, it doesn't really matter. But we need these pieces of information. So can someone tell us what's the base? What's the base? Two people know what the base is? Let me ask a different question. Put your hands down. Where do I find the base? Like literally, physically, where do I look to find it? At the bottom. So everyone look at the bottom of the triangle. From here to here is the base. But now I need a value for it. What is the base? There were some people who had their hands up. Isabella?
X.
X. I don't see an X anywhere.
It was on the rectangle.
Ah, it was there. It was on the rectangle. So if I take away my whiteout, why can't I take away my whiteout? If I take away my whiteout, now you can see that this X is the same as this because that's the definition of a rectangle. Definition of a rectangle, this side and this side are equal to each other. So her explanation was fantastic. This is X. So now we have the base. What's the height of the triangle? What's the height? Yadesh? 10. The height is the distance from the top point down to the base. So that's 10 right there. So now plug in the pieces of information. We got 1/2 the base times the height. But remember, it's multiplication. So we can rearrange this in any order that we would like. So if I wanted to, I could change it to 1/2 times 10 times x. That might make a little more sense. Let me back up, because now people are looking at this going, well, okay, Mr. Gallup, but I have no idea how to do that. So let me back up to here. What's half of 10? Briante? 5. So in actuality, this is 5. And so this is really 5x. And so that's where we get the 9x from, because the rectangle is 4x. This is really 5x. 4x and 5x is 9x. So does anyone have any questions on how we found the area of the triangle? So then we find the area of the rectangle. Base times height. Base times height is 4x. Does anyone have any questions on how we put all of this together? No questions? Concerns? Okay, move the warm-up to the side of your desk. Today we're going to explore decimal equations. And not a lot of new ideas in today's lesson. We're just going to explore equations and see what happens when there's decimal involved. We're going to use all the same techniques that you've already learned. But I am going to take this opportunity to explore the idea of rounding numbers as well. So that's where we're going to start. So everyone has a table like this set up. You should have these terms across the top: hundreds, tens, ones, tenths, hundredths, thousandths. Now, I did some research online before setting up this lesson, and I figured out that somewhere around 1st and 2nd grade you learned these words: ones, tens, hundreds. So that shouldn't be any issue. Somewhere around 5th or 6th grade you were supposed to have picked up these words, the decimal words. You should notice that the word tenths is the same as tens, except there's a th in between the n and the s. And it's pronounced tenths. Now, I always found it curious why there was ones here. Why isn't this called oneths? Because to me that would seem more balanced, right? If it was ones, oneths, tens, tenths, hundreds, hundredths. Does anyone know why this is not called oneths? Why is it called tenths? There is a reason. A very good one. Alex?
This is like, let's say if you go like 0.2, that's actually equal to like 20% or something like that.
Okay, you're onto something there. So let's stick with that example. 0.2. Why is it not 2 oneths? Why is it called 2 tenths? Yvonne?
I think
Well, yeah, it has something to do with decimal. Caesar, and then Briante, and then Valerie.
It's called 2/10 because it's part of the 10, like, portion of it. So, like, it's like 10 pieces, so it's like 2.
Okay, very good. That's actually an outstanding way of explaining it. Let's see what Briante and Valerie were going to say, and then we'll kind of put it all together.
Because you know how you get 100 is 1 point. Since like since after before the since before the decimal it's gonna say like 0.2 or 3. That means it's tenths because it's the second number before it's
Okay. Not sure if I completely understood your theory, but you were onto something there. You were onto something. Valerie?
I don't think because anything considered as 1 is a whole, and anything after the decimal point is something.
Okay, very good. Now, if you take what you just said and put it together with what Caesar said, that kind of puts it all into perspective. What Caesar was saying was really important. If we put 0.2, what that really means is 2 out of 10. That's what Caesar was saying, was that tenths means there's 10 pieces, and we've got 2 out of the 10. 2/10. That's why it's tenths and not oneths. It's not a 1 in the denominator, it's a 10. Okay? So you have to know these words off the top of your head. If I tell you to round to the hundredths place, you have to know that we're talking about this column right here. If I tell you you need to round to the tenths place, you have to know that it's this column here. You have to know the words instantly off the top of your head. So let's do an example. So everyone fill in these numbers. Well, those digits. It's actually one number. So we're going to look at the number 147 and 379 thousandths. Most of us say 147.379. But this part of the number is 379 thousandths. Now, in my research, I also looked up different ways of talking to you guys about rounding, different techniques. If you had Ms. Cooper last year, she taught you a little catchphrase, a magic phrase to help you. Does anyone remember the magic phrase Ms. Cooper taught you last year to help you remember what to do? It's going to be a kick yourself moment for some of you, because once it's said out loud, you're going to be like, oh yeah. Caesar?
It was 5 or above. Some number show, something like that, and then 4 below.
Oh, you kind of made up your own. Ms. Cooper has something like that. Go ahead.
Well, it's not Ms. Cooper, but my teacher talks to me and says 5 to 9 up the vine, 4 below on the floor.
Something like that. And I know you're trying to remember from a long time ago. So here's Ms. Cooper's, which I love. 5 or more, raise the score.
Oh, yeah!
5 or more, raise the score. So, I told you you're going to have that moment. 5 or more, raise the score. Now, the thing I always like is that, yes, there's another part of it. I 4 or less, give it a rest or something like that. But you don't have to know the second part. You just have to know one part. 5 or more, raise the score. Well, if it's not 5 or more, then don't do anything. 5 or more, raise the score. So that's a good thing to remember, but what does it mean and how do we use it? So what we're going to do is round to the nearest hundredth. So one thing that I saw online, a bunch of different teachers talking about their techniques, a lot of them used circles and underlines. I honestly don't really care how you focus, but the idea is to focus in the right place. If I ask you to round to the hundredths, we could circle that number. What that means is when I rewrite the number, that's the last digit that I'm going to have. There will not be any digit here. So rounding to the hundredths means that's the last digit. So then we use this number to tell us what to write. And that's where Ms. Cooper's technique comes into play. 5 or more, raise the score. If this number is 5 or more, raise the score of the number in the circle. So, is this 5 or more?
Yes.
Yeah. So, raise the score. What will the 7 turn into? What will the 7 turn into? Gloria? An 8. And so what we end up with is 147.38. Does anyone have any questions on how we did that? So let's round to a different place. Now we've got the number 81 and 521 thousandths. And this time I'd like to round to the nearest tenth. That's how you'll see it in the book or workbook or review when we review for FCAT. Nearest tenth. So we're going to round to this place, which means when I rewrite the number, there won't be anything in these place values. This will be the last number. But I use this number to tell me what to write. And now we use Ms. Cooper's magic phrase. 5 or more, raise the score. So what do I do to the number I circle? What do I do? Selena? Keep it the same. This is not 5 or more, so this stays the same. So we get 81.5. Does anyone have any questions on how we did that? Good. So my expectation as we continue is that you are becoming very comfortable with this, and that you will be able to continue doing this throughout the rest of the year without me prompting you on what to do. Okay? So let's do a couple more quick ones, going a little bit faster. This is the one that I tend to see the most struggle with, although I don't think you guys will necessarily struggle. To the nearest whole number. When you're asked to round to the nearest whole number, what place value are we really focusing on? Yvonne? The ones. The nearest whole number means the ones place. And so we are going to round to this number, which means that's going to be the last digit. So in this case, we actually will not necessarily have a decimal, and we won't have any numbers in these positions here. But we do need this number to tell us what to do with that one. So what will this number, 9 and 42 hundredths, turn into? Rashida?
Stay the same.
So what will it be? 9. Comments or questions on any of these? I wanted to show you one last special case, and this does get a little bit tricky. 884 and 999 thousandths. And we want to round it to the nearest hundredth. So we already did an example of that up here, rounding to the nearest hundredth. So we know we're going to look here. This is going to be the last position in our rewritten number, so we're not going to have a digit here. But watch what happens. 5 or more, raise the score. What do I raise the 9 to? What do I raise it to? Isabella?
You put a 0 in the place and you add a 1.
Okay, So technically, what am I raising it to? 10. But you can't write a 10 here because each box gets one digit. So her explanation was very good. We don't put the 10, we put the 0 here, and then we put the 1 here. But watch what happens again. Now I've got 9 and 1, now I got a 10 again. I'm not allowed to put a 10 here. So again, we have to do the same thing again. We put the 0, and then we put the 1 over here. So what does the number become? Gary? 885. Does anyone have any questions on how we did that? Any questions on any of these? Okay, now we're going to apply this a few times, not too many times, throughout the lesson. Today we're really exploring equations that have decimals in them, and we want to see what happens. At this point, you should be very, very comfortable with the process. I walked around, I was very impressed with your homework performance. You guys did a really good job. So let's go do the fast version. The steps should be now going really fast through your head. You've done like 100 to 150 equations already. You should be very comfortable. So where should I be looking in part A? Like, give me specifics. What should I be looking at immediately? Danae? Very good. And Chanel, what operation is happening in this equation? Very good. So the first thing we do is we draw our t. And since we're doing multiplication, how do we solve the equation? What's the action that I'm going to take? Michael? Division. And I was very impressed that I saw you guys doing this on your homework. Those of you who did it, and most of you did, it was very good. But here was the tricky thing that a couple of people are still making mistakes on. What do I divide by? What do I divide by? Jedli? Okay, and that's actually the mistake that a number of students are still making, is that we're not dividing by the opposite. Remember, the number is always the same. The only thing that's flipping is this operation. This was multiplication. The division is the inverse. The number stays the same, so we divide by negative 5.24 on both sides. And now we work down. So this cancels each other out because it becomes a 1. And we're left with x equals, and now we're going to have to use our calculator because we can't do mental math with this. So pick up your calculator, the required equipment for my class. And what do you get when you do that division? Got 3 people who can confirm, Gary and Yadesh, and then Leah. What'd you get?
Negative 3.75.
Okay, what'd you get? Negative 3.75. So everyone got negative 3.75. Very good. So I can feel confident that that's the correct answer. Does anyone have any questions on how we solve this equation? Any questions? Yes. Okay. Oh, I wrote a wrong number here. It was just a mistake. This was supposed to be a 4. I apologize for that. Is that what? Maybe you punched in a 5 instead of a 4. I wrote a 5. That might be why. I apologize for that. I hope I didn't mess up anybody else. That was supposed to be negative 5.24. I wrote it the correct way on one side, but not the other. Any other comments? Did you check again? Is that what happened? Okay, thank you. Any other questions on part A? So now we're going to skip over all of that. The where to look part is now automatic. So now we just skip to what are we doing? So someone just skip all the way to what do we do? What's the action? Chris? Adding what? Good, but now say the whole thing. That's it. Very good. That was perfect. Adding 31.33 to both sides. And again, we're working down. F and nothing is F. This minus plus cancels out. And now we just have to add this down. What do we get when we add that down? Okay, we got Yadesh, Jedli, Isabella. Confirm for us. What'd you get?
12.26.
Okay, what'd you get, Jedli? Okay, Isabella? 50.4. Okay. So we have some disagreement. Gloria? Okay. So we have a lot of agreement on that. Unfortunately, we all agree on the wrong answer.
It's 12.26.
So let's explore. Since look up here, please, because most of your make sure you're able to do this with your calculator. I've been encouraging you this entire year to learn ways of doing mental math efficiently. But negative 19.07 and 31.33, not easy to do mentally. So we need to use our calculator, but you have to use it correctly. 19.07 is negative, so watch what you do in your calculator. 19.07, and then there should be a plus minus button somewhere on your calculator. You push that button and you turn the number negative. Now add 31.33 and you will get 12.26. So, and I can give you an FCAT calculator to use so that you can see it, but you have to be able to use the plus minus button effectively and correctly on your calculator. So anyone not able to find their plus minus button? I see yours. You should, I know you have one. So if you don't have a plus minus button, what you can do. Yeah. If your calculator doesn't have that button, it can still do it, but it works very strangely. You actually have to push the subtraction button, and it actually might not show up, but it's actually doing it kind of in the background. So if I push it 3 negative, plus 6, it actually did it correctly. It actually did it correctly, but it's a little hard to tell what to do. But don't worry, during the FCAT, you will have an FCAT calculator. Okay, one last thing. Do not copy part C. I just want to show you something. Do not copy. Everyone look up here. So you already know what to do. We draw our T. But what's the action we take for solving an equation that looks like this? What's the action we take? Rashida? Good. So Michaela, we multiply. What do we multiply by? Very good. But here's what I didn't really talk about last time. I have a lot of people doing this. That's actually not what we're doing. If you multiply this times this, you're going to get a very large positive number on the bottom. That's not what we're doing. We're multiplying the top. We're actually multiplying the top by this number. We're multiplying that. Because when we have a number on top of a fraction and on the bottom, when we have this, what do we end up with? Kivan? We do not end up with 0. What do we end up with when we divide a number by itself? Danae?
1.
1. And that's our goal, is to get a 1. So this is actually being multiplied on the top, not on the bottom. So those of you, there were a couple people I saw who were writing it down here. That's not correct. I didn't talk about that because I was trying to help you just get through the concept of solving an equation. But now I'm correcting that, that behavior, okay? Any questions about that? All right, let's see how you do on your own. Checkpoint number 1, solve each equation. You got 2 equations, you got 2 minutes. All right, let's see how we're doing. What do we get for part A? Got 1, 2, 3, 4, 5 confident people. We'll start with Selena, Jedley, Isabella, Garion. What'd you get?
I got negative 6.0.
Okay, what'd you get? Jedley?
6.
So we have a disagreement. What do you say, Isabella?
Negative 6.04.
So you agree with Selena, Garion?
I got negative 6.04.
The correct answer is negative 6.04, and I actually have a typo here. It is supposed to be negative 6.04. What about part B? What do we get? We'll start with Rashida, Kevon, Michaela, Valerie.
76.9.
Okay, what'd you get?
76.9.
Okay, so you guys agree?
76.9.
3 people agree. Everybody agrees? That's good this time because that is the correct solution. Comments or questions on how we did that? Isabella? Okay, what did you get?
82.
Okay. Well, first let's check and make sure you copied the question right. Is this the D minus 50.18 equals 26.72? Okay. And so we draw our T. Is that what you did first?
Yes.
And then what action did you take? Good. You added what?
50.8.
Good. 50.18. 50.18. So you did everything right. My guess is if you used the calculator, you punched in something wrong. Yeah. So think of it this way. Watch this. You should, when you're using a calculator, everybody watch. Not just people who got it wrong or right. If I take this off and I take this off, you should be able to add that mentally, right?
Yes.
So you can take a quick estimate of what your answer is going to be. 26 plus 50 is 76. You know your answer should be near 76. Now use the calculator. You know it should be somewhere near 76. Okay? That make sense?
Yes.
Good. Comments, questions? Okay, so now let's take it to the next level and apply it to geometry ideas. So you can sketch the diagram. Doesn't need to be perfect. So of course, if you picked up your calculator already and started trying to find the answer, that would be a dramatic mistake because that defeats the purpose of what we're doing. What we're trying to do is to learn and prepare ourselves for algebra. And so next year when you have a much more complex version of this, punching numbers in a calculator is not going to work because you're not going to actually know what to do. So we're not trying to just find the answer. We're trying to establish the process. When we're working with real-world scenarios, in my classroom, what's the first thing we try to find? What's the first thing we try to find in my class? Michaela? The total. Always try to find a total first. Is there a total in this question? Raise your hand and if you think you know what it is. Gloria? Yeah. The total is this number here. So why is that so important? Because when we write an equation, at least at this level, we start out by writing 66.64 all the way to the right. That lets us focus on, well, what has to come out to 66.64? What would have to be here to equal this? And that's our goal now. To be able to do that, you have to understand this word. What does that mean? What does that mean? Briante? But that's good that you caught that little mistake that you made. That was excellent. Because it's not the area around. Does anyone know what word she should have used? Grace? Distance. But that's what you were trying to remember, and I know you know it. And what was the example in my classroom that I used last time we talked about perimeter? There was something physical in my room that I referred to. Valerie? Yeah, the gray molding around my classroom is the perimeter of this room. And so the distance around. Now, how do we calculate the distance around? What operation are we going to do to find it? Rashida? Add up all the sides. And it does not matter the order because we're adding. So it could be this side plus this one plus this one. It doesn't really matter the order. 26.14 plus x plus 21.43. And now we've established an appropriate equation to solve. Now, it would be nice if the equation looked like this, because I know how to solve that, but it doesn't. And it would be really nice if the equation looked like this, because I know how to solve that, but it doesn't. So how do I get it to go from this to looking like that? What do I have to do to change it? Mia? Yeah, you combine like terms first. You combine this and this into one term. And what do we get when we add those two terms together? What do we get? So we got a bunch of people who did it. Go ahead, Mia, you're on a roll.
It equals 47.57.
Yeah, so we end up with this equation. Now we're ready to solve. So we draw our t, and we solve the equation. What's the action we take? Janae?
Subtraction.
Good. Subtract what?
We subtract 47 from 27.
Very good. Before you use your calculator, although I'm guessing some of you already did, could we take an estimate of what's going to happen when we just do the 66 minus the 47? I know what I do. What would you say that that's going to be close to? It's going to be close to 19. What I do in my head is, since that's a 47, I change that to a 67, and I say 67 minus 47 is 20. He knew it was 19. So I know that this answer, when I do it, is going to be somewhere near 19 or 20. So now when I punch a number in the calculator, if I punch in something wrong, I'll know it because the answer doesn't really match my estimate. So now let's get the exact answer. What do we get when we subtract it? Go ahead, Mike. 19 point. You get 19.07. Sounds about right. Does anyone have any questions on how we did this? Gary?
What if you did it 66.64 minus 26.14 plus 21.43?
Did you get the same answer?
I got the same answer, but I did it different.
That's fine. But the idea here today was to be able to set up an equation. So let's see what you can set up with this one. Checkpoint number 2. You got one question, you got 2 minutes. All right. So looking for the solution first. What did we get for the missing side? What do we get for the missing side? We got Valerie, Briante, and then Kivon. Okay. Okay, big disagreement. 9.4 feet, so you agree with Valerie. So the correct answer is 9.4 feet. So give me a thumbs up if you got this question correct. Keep your thumb up if you can give me the equation that you used. Good. Put your thumbs down. Chanel, what was the equation you used? Very good. That is exactly what we were looking for. That is the equation that we needed to set up because the area of a rectangle is base times height. Base times height. So that leads you to that. Comments or questions? We're doing quite well. Draw a line across your paper. Your classwork is in the textbook, page 105. You're going to do 7, 8, 9, and 10, and 37, 39, and 43. Got 10 minutes. Go ahead and begin. Bless you. Okay, colored pens up, and let's see how we are doing with decimal equations. Number 7, 8, 9, and 10. Number 7 is 5.4. Number 8 is negative 1.6. Number 9 is negative 41.18. Number 10 is 0.25. Number 37 comes out to 2.1 square meters.
What if you just put 2?
Number 39 was negative 4.5x. And number 43 is 6.4 feet. A couple of things to note. For number 37, it had to be 2.1. If you didn't put square meters, I'm not going to go crazy right now. Later on in the year, we will talk a lot about units of measurement. Same thing for number 43. If you didn't put feet, you can still mark it correct if you put 6.4, but you should be putting units of measurement. But again, number 37 had to be 2.1. Number 37 said round to the nearest tenth. To the nearest tenth. Comments or questions on any of these? Okay. Draw a line across your paper. Your homework is page 105. You're doing numbers 24 to 44 even and 48 to 56 even, and you're going to skip number 36. That works out to 16 questions. And you will have a test on chapter 2 next week.